Okay, many of you are going to want to know about some practice problems. So we're going to do some practice problems for the Circles 101 presentation. Now, there's a couple quick theorems I forgot to mention in the presentation. That's the chord arc theorem and the converse to the chord arc theorem, which should be pretty simple. In a circle and congruent circles, the arcs of congruent chords are congruent. So if the chords are the same length in a circle, well then the arcs have to be the same measure and the same length. Likewise, in a circle or congruent circles, if the arcs are the same, well then the chords have to be the same. Pretty simple with regard to that. Okay, now let's go to the problems. Here are some problems for us to look at that'll be similar to what you see. So we see up here in the left-hand corner, find the center and the radius for each circle, and then that top right, write the equation for the center and the radius given. Okay, so here's how we do that. If I write this as x minus h and y minus k squared equals r squared, that's what I want to look at for my squares. Well, what I have here for the first one, there's nothing in there with the x, so the h must be 0. There's nothing with the y, so the k must be 0. So that means my center is at 0, 0. And the 169 is my radius squared. So the radius is the square root of 169, which is 13. Not bad. Okay, so let's take a look at the next one. X minus h, so I got to change this to x minus a negative 2 squared plus y. Again, there's nothing there, so I'll put a 0. Squared equals 6 squared this time. 36 square root of 36 is 6. So my center is at negative 2, 0. And my radius is 6. Okay, so now the last one's already in the x minus h, y minus k format. So my h is 6, my k is 2, so that means my center is at 6, 2, and my radius is the square root of 25, which is 5. So that's how we do those. Now, what if they say, here's my center, here's my radius, write the equation? Well, I'm going to say x minus squared plus y minus squared equals squared. So I'm going to put the 3 over there since that was the radius. I'm going to put a negative 3 in here with the x. I'm going to put a 4 in there with the y. I could leave it like that because it's the right answer. But minus the negative, we really don't want to see it that way. And it's really nice to go ahead and square that last number. So for the first one, I would have said x plus 3 quantity squared and y minus 4 quantity squared equals 9. Now for the last one here, x minus 4 squared, y minus 6 squared equals 8 squared, or you could say 64. So that's how you do those part right there. If they're giving you the equation and they want you to work through it. Now the other part that goes with this is writing the finding the x and y intercepts. So when I go to graph this, I want to know where this thing happens to hit. Excuse me. I want to know where these things happen to hit the x and y axis. I want to see if it'll happen. So now, here's the first thing to notice is I got an x squared and a y squared, and I'm equaling 169. Good thing to know. Now, x, y intercepts. What do we know? X-intercept is where the graph crosses the x-axis. Well, that means the y has to be 0 at the x-intercept. At the y-intercept, that's where I want to cross the y-axis. So that means the x has to equal 0. That's how I do these problems. So if I want to find the x-intercept, I'm going to let my y equal 0. So I'm going to get x squared plus 0 squared equal 169. So that means x squared equals 169. So what number times itself gives me 169? Or I can say I have the positive or negative square root of 169. Well, the square root of 169 is 13. So that means my x-intercept is either at 13 or negative 13. So my x and y intercepts are at 13, 0 and negative 13, 0. Because my y value is negative, and I have two values that can make this work. Now, if I want to find the y-intercepts, this time I'll let the x equal 0. So I get y squared equals 169. Well, that means I'm going to have the same thing. Y will be a positive or negative square root of 169. Well, the square root of 169 is 13. So y is a positive or negative 13. So my y-intercepts for this one are going to be 0, 13, and 0, negative 13. So if their center's at the origin, your intercepts are all going to be pretty much the same. You're going to have whatever that radius length is, positive, negative, and then zeros. Now, notice on 13 and 15, they change things up a little bit. They give you a different point not at the origin. Okay? So if I want to find the x-intercept again, I'm going to let x plus 2 squared, plus I'm going to put the 0 in for the y. 0 squared equals 36. Okay, so that's important. Because now what I'm going to do is I'm going to treat that, scratch all that out there. Let me put a big block over the top of that, just so I can write without having to run into anything. Okay, so x plus 2 squared will have to equal 36. Now, there's many different ways we can go about solving this. The easiest, though, is go ahead and treat the x plus 2 as a variable itself. I got something squared equaling 36. So that means that something would equal a positive or negative square root of 36, which is a positive or negative 6. Square root of 36 is that. So that means my x plus 2 could equal 6, or my x plus 2 could equal negative 6. Well, that would mean my x equals 4, because 4 plus 2 is 6, or my x equals negative 8, because a negative 8 plus 2 equals that. So my x-intercepts are at 4, 0, or negative 8, 0. Now what about my y-intercepts? My y-intercepts, I put a 0 in for the x. So if I put a 0 in for the x, I get this equation. Now if I solve that equation out, 0 plus 2 is 2. So I got 2 squared plus y squared equals 36. Well, 2 squared is 4. So 4 plus y squared is 36. So that means y squared is 36 minus 4, or 32. So that means y has to be a positive or negative square root of 32. That doesn't have a nice whole number. I'm just going to leave it like that. So I have a 0 square root of 32, or I have a 0 negative square root of 32. Okay, nice and simple there, right? Okay, so those are the tougher problems. Now, what about this last one? I'm going to have to do the whole same thing again with the, put a 0 in for the x, put a 0 in for the y. Now, here's something I want you to realize is, I have a center here at 6, 2. Okay? And I have a radius not equal to 0. I have a radius equal to 2. What that tells me is it's never going to cross the y-axis. And the reason I say that is I'm 6 units over with the x. This x value is 6 units to the right. I moved this whole thing 6 units to the right. I only got a radius of 2. 2 is not bigger than 6. It's never going to make it to the y-axis. There's no y-intercepts. I notice that my y value here and my radius are exactly the same value. My y value and my radius are exactly the same value. That tells me I'm only going to get one x-intercept. And that'll be at 6, 0. So I'm only going to get it at that one point where the radius hits the circle. Now, what if this radius here, and if I do my eraser, you'll see that there was actually a different number here before. It said the radius was 2. Well, that means, or sorry, the equation originally said it was 2. That means my radius was the square root of 2. Square root of 2, if I go to the calculator, is about 1.414. Okay? Now, as I look at my center point and I look at my radius, I notice that 6 is greater than 1.414, and 2 is greater than 1.414. So in this case, neither one of them would have an x and y intercept. Now, is there another option to do this? You betcha. How about GeoGebra? If I just do GeoGebra, hey, I see where my center is, I see where my radius is, I go ahead and put it in here. I do my center with a point at, and I make sure I put it in exactly how it is. So I have a radius at 6, 2. So I want to make sure I get my point out here at 6, 2. And I didn't quite get 6, 2. And my radius, our original problem I gave you was 2. And we can see where it hits exactly right at the 2. I wonder if I can change this. Oh yeah, I can type the point in exactly like I want it. That way it moves it over. There we go. Now take a look. I see I only have that one point right there. That's at 6. So at 6, 0 is my only x-intercept, and I see that it never crosses the y-axis. So we could always go back to GeoGebra to find those. Okay, so that's dealing with the equation. Now, let's get down to the other stuff. Find the degree measure of each arc by using the central angle to give the measure. So, I want to find the measure of arc AC. That's this arc right here. That has to be the measure of its central angle. Well, here's its central angle. It's those two added together. So 70 plus 84 gives me 154 degrees. All right. Arc CBF. I notice it's got 3 letters. I know it has to be more than half a circle. CBF right there. So its central angle is from C to M to F. It's going to be those 3 numbers. So 86 plus 84 plus 70. And if I add that up, 86 and 84 is 170 plus 70 is 240 degrees. Okay. One last one. ADC. ADC right there. We got a problem. It would be 86 plus 34 plus the measure of angle CMD. But I don't know that measure. I have 2 ways to do this. I could take 360 and subtract all the other ones and get it. Or I can notice that this arc here is on the other part of the circle from our ABC one. Remember, our first one was arc AC. That's the A to B to C one. And that was 154. So this has to be 360 minus 154, which should give me 206. So that's a 206 degree angle, right, or arc right there. So that's how we can do those problems. Now, the next set of problems here, I know I'm going through these quick, but you can always go back and replay them. Okay, determine the length of an arc with a given central angle. Measure angle W and a circle with a radius R. Round your answers in the nearest problem. So this goes back to that formula, M over 360 equals L over 2 pi R. I know my M is 240. This is 360. And I know my R is 3/4. So that's L over 2 times pi times 3/4. If you want, you can change that to 0.75. Okay, I'm just trying to find L. So here what I do is I see I have a proportion I'm going to cross multiply. So I have to take 240 times the 2 times pi times 3/4. And that's going to equal 360L. So if I divide by 360, I get my L by itself. Okay, so 240 times 2 pi times 3/4 divided by 360. And I really would recommend using the whole pi on that. And I get my answer to be 3.14. Okay, so the length of my arc there is that. Okay, determine the degree measure of an arc. I know my L, I know my R. Hey, same formula. M equals 360. I put in my L is 15. My R is 2 pi times 12. So I just used the same formula again. I plugged in my new numbers. Now I just do the cross multiplying again. So this time I see 360 times 15 would have to equal my 2 times pi times 12 times m. Well, again, if I divide by the 2 pi, 2 times pi times 12, I will get my m. So 360 times 15 divided by, I'm going to put parentheses here, 2 times pi times 12. Okay, 360 times 15 divided by 2 times pi times 12 gives me 71.62. So my m is 71.62 degrees. Okay, so that answers how to do those problems. Now, determine the length of a radius of a circle with the given central measure angle and the given arc length. Hey, now I know my L and my W, but I'm trying to find my R. So now I know that 213 over 360 has to equal 21 over 2 pi times R. Well, now I'm just solving the same proportion for R. So 213 times 2 pi R has to equal 21 times 360. So that means R is 21 times 360 divided by 213 times 2 pi. Now when I plug this into the calculator, I'll go 21 times 360 divided by parenthesis 213 times 2 pi, close my parenthesis. And I find my radius to the nearest hundredths is 5.65. And then whatever the unit is. Okay, so last part. Find the circumference and the area for a circle given the radius is 12. Circumference is 2 pi r, and area is pi r squared. So now all I got to do is plug in my numbers, 2 times pi times 12, and pi times 12 squared. So this gives me 144 pi, and this one gives me 24 pi. So those would be my exact answers, but it told me here to use 3.14 as pi. So 24 times 3.14 is 75.36. And 144 times 3.14 is 452.16. Now this one would be units squared because it's area, and this will just be units because it's a circumference, it's a length. Okay, so those are our problems there to help us out.